Hello everyone, welcome to another instruction video for using Mastercam. We're going to do this video to help you complete your homework number 3 assignment, which is your Fidel figure mold. Um, be sure that before you load your project file that you read the homework 3 instructions thoroughly. It will not only tell you where to get these files from so you can download them, but also it will give you the step-by-step instructions that you need to follow in order to complete this mold properly and successfully. Once you've downloaded your file, there's another video that you're going to probably want to make sure that you watch first, and that's the one that's called Pockets, Contours, and Engraving. I did a video prior to this one that showed just simple pocketing on some of the simpler molds like the heart, the teddy bear, and the gingerbread man. But this video is for those projects that combined the pocketing with contouring, and some of them the pocketing, contouring, and even the engraving. So this is a perfect project that'll just demonstrate all three, and you can use these concepts with whatever mold that you happen to have chosen. So the first thing that I want to talk about once you've loaded your file in is to make sure that you're going to save it as something else. So go up to File, use the Save As command, and save it as another file name just in case something happens to your original here. You don't have to go back to the website and download it. Once you've saved your file, you're going to want to plan your strategy. So I've said this in previous videos that every good designer and every good engineer uses visualization and plans out what's going to happen and has a good idea of what those results are going to be before they start jumping in and doing things. And this is no different. Even though this is a simple mold project, you're going to want to take a look at it. You're going to want to read all of the instructions that are on the screen, and then you're going to plan out the order of your strategy so that you have the best success. For this particular project, the notations that are on the screen, you want to make sure that you see all of them and that everything is turned on. And if you're not familiar with levels, if you go to the bottom left of the screen here and click on the Levels tab, levels are like clear panes of glass or transparent pieces of paper where you can draw geometry and put notation on each one of those layers of glass or paper, and then turn those layers on and off. So in this case it's called levels, and some CADs they call them layers. They're both exactly the same thing, and the purpose is for organization and efficiency. So in this case we have three different levels, right? We have the main level, the notes level, and all of the engraving stuff that we're going to do, the doors and the windows, etc. You can turn the levels on and off by just clicking on the visual column, just turning that X off. I'm going to turn off the notes, and you can see now all I'm seeing is the truck body itself along with the doors. We can turn the doors and headlights off, and now I'm dealing with just the tires and the truck body itself. So you can see how this can help you concentrate on just an area and not have things cluttered up. To turn all your levels on, you can use this icon up here. It says turn all levels on, and everything turns on. And then what you're going to want to do is right click in the graphics area somewhere and click the fit icon. That will ensure that everything that is turned on is now visible to you on one screen. I'm going to go back to the Toolpath menu now, and you're going to notice that there's 4 operations that have already been done for you. Now these 4 operations are for creating these dowel pin holes that are in your mold. So the 3 F's, fit, form, and function, applies to everything that we make. And in order for this mold to function properly, these dowel pin holes are used to put in steel dowel pins that will allow the 2 mold halves, once we split it in half, to perfectly align and to tightly align as well. In order to do that, it takes these 4 operations to complete it. We'll use a centering drill to spot the holes. That's going to put the holes on location. We'll use a drill to drill the holes, and we'll undersize drill them because drills typically will drill oversized, and we don't want a sloppy hole. Then we'll come back in with a reaming tool, and that reaming tool will size it to a 4th place decimal. And lastly, we'll come in and use that centering tool again to come in and engrave a scribe line down the center so that you know where to line it up on the bandsaw to split your mold in half. We'll also use later on in this example video that same center drill to come in and do the engraving of your doors and tail lights and headlights and whatever else you might have on your engraving for your particular mold. So please don't touch these operations. They've already been created. the depths are set, the feeds and speeds, and the proper tooling is being called. If you go in there and accidentally change something, you can cause a serious crash on the machine, which can then end up not only damaging your part, but also maybe causing injury to you or someone else. And of course, we certainly don't want to damage the machine either. I'm going to begin my strategy here by taking a look at these different notes. And I personally would want to do the pocketing of this truck body first. I mean, we're always going to do our engraving last. So I'm going to turn off the doors and the headlights in my levels. I'm going to go to my levels tab, and I'm going to turn off that part of it. I'm going to then go back to my Toolpath menu, and I'm going to read that it says for the truck body I should use a parallel spiral pocket operation, and that's going to use tool number 5, which is a 3/8 end mill running at 12 inches a minute. To create that pocket routine, I'm going to right click on the Toolpath menu here, and I'm going to slide down to pocket. Now I'm going to move through the parameter settings for each one of these tool operations rather quickly. And the reason why I'm doing that is because you should have already have watched the video called Pockets, Contours, and Engraving, where I go into a little bit more detail on what each setting does and how to use it. So again, we're going to choose the chaining option here. I want to chain in a counterclockwise direction, which means I need to pick the truck body down here and also over here. That sends the chain in a counterclockwise direction. Once I've done the truck body geometry, I'm going to click OK. I'm going to go to my tool menu, and remember I described these tools already because they're going to be doing the center drilling and the drilling of those dowel pin holes. I need to create that tool 5, which is the 3/8 end mill. To do that, I'm going to click on Select a Library Tool, and just in case end mills aren't selected as the tool type, you can go into Filter, and you can either turn all the tools on or off. In this case, I make sure none are selected except for the end mills. And then I'll say OK. And then I'll go down the list until I find the 3/8 flat end mill. I'll click it, and it's going to give me some random tool number. And remember, we need to set it to tool 5, so we're going to come in here under tool number and click 5 and then press the tab button, which will populate the tool number, the length offset, and diameter to be the same. And remember, these all 3 must be the same. Let's set our RPM to 1600 RPM. Let's set our feed rate to 12 inches a minute. And let's put in a comment in here that says pocket truck body. Comments, as you know, are optional, but I like to put them in because then I know what it's doing. We'll come down to cut parameters. We'll make sure that the pocket type is standard, and we want to not leave any material in the pocket walls or floor. So we're going to change these values to 0, and then we're going to click on the tab button to make sure it accepts it. And now I'll go into roughing. Remember, the strategy that we're using here is parallel spiral, so we'll choose that as our strategy. We'll accept the default of 50% overlap. We'll go into our entry motion tab. We'll make sure that helix is selected, and we'll change our Z clearance value from 0.1 to 0.01. Now we'll move to our finishing operation. We'll make sure that we leave 10 thousandths on the walls and floor to finish. We'll make sure that the computer will do the cutter compensation calculations for us, and we'll use the lead in and lead out values here. We'll change that to be perpendicular. The length that will lead in will be 0.1, and the sweep angle that will sweep in after we lead in with our 0.1 will be at 45 degrees. Now the entry we want to be the same as exit to be the same as entry. So to copy these values over, we'll use this little copy button here, and now both will be exactly set to the same. Remember that cutter compensation has to have a lead in. It can't just come down on a line somewhere, because then it'll gouge that area, and then as it engages itself, it'll slowly cut a crooked line until it's tangent with whatever piece of geometry it's cutting. So by using these lead in and lead outs, it ensures that cutter compensation starts off the work, engages itself properly, and then does the proper cut. We're going to skip depths of cut. We're just cutting soft plastic, and we're only going to go 0.1 deep, so we're going to make sure that we do this at a single pass. So make sure that this red circle is on. If it isn't, then you just simply click into it and take the check mark off. Same with breakthrough. We'll click on linking parameters. We're going to turn on our clearance. We're going to make sure that all of our values that we input are considered to be absolute values. We're going to set our clearance height to 1 inch, our feed plane level to 0.1, and the depth of cut for this mold, negative 0.1. Now we're going to slide down to the coolant, and we're going to turn on flood coolant, and then we're going to click OK. So our two pockets have now been created, and if we want to look at that operation, we'll expand the operation here, and we'll click on Toolpath, which will bring up the back plot, and we'll click on the play button, and you'll see that the tool is coming down at 0.1. I'm pushing my middle mouse wheel here and sliding up so that you can see the depth, that I'm 0.1 below the part, and then I'll return it back to the top view here so you can see it finish the pocket. And once it does the pocket, it'll go back and do the final 10 thousandths contour. The yellow lines that you see are rapid moves where the tool is coming up and out of the mold. So that pocket routine looks great. I'm going to say OK. If the toolpath stays on the screen, you can toggle it on and off by pressing and holding the Alt button and pressing T. Here's where I toggled it on, and here's where I toggle it back off. Our next operation is going to be cut these tires. And to cut the tires need to be cut at Z minus 125 thousandths. So that we're going to take using the same end mill, the T5 end mill, but rather than doing a pocket, we're going to just do a contour, because the size of these tires, there's no need to pocket it out. Once we run the end mill around one time in a circle, it will create the entire tire for us all cleared out. So I'll right click here. Mill toolpath will be a contour type, and we're going to use the single toolpath method. And in this case, I'm going to click on the tire here, and I want to make sure that the arrow goes counterclockwise. All right, so I'm going to click the tire here. I'll click it here. Notice it's not going counterclockwise, so I'm going to click the reverse button on that one, and I'll click this one down here. So now all 4 tires are going counterclockwise. It's a good point to note here that every time you want to change a depth on something, you need to do a new operation. That's why we did a pocket operation at 100 deep here. These will be done at 125 thousandths in a separate contour operation. I'm going to click OK. I'm going to go to Tool. This tool is that we're going to use again is this Tool 5, so I'm just going to click it. I'm going to ensure that the Tool 5 has the proper numbers in all 3 of these registers. We're going to again go to 1600 RPM. We're going to go to 12 inches a minute, and we're going to make sure that rapid retract is selected, and when we plunge down into the material, let's plunge down at 6 inches a minute. Here I'll say mill tires. Under our cut parameters, I'm going to turn our cutter compensation. Now we want to keep the tool on the inside of this line, so we want to make sure the cutter compensation is set to left. And we'll use the computer to help us calculate the cutter. Now notice this graphic now shows the cutter will be on the left side of the line, which is climb cutting, again, which is one of the methods that is preferred by CNC programming. We'll make sure that we're not leaving any stock, so this needs to be set to 0. Our contour type needs to be 2-dimensional. We're not going to use depth of cut. The lead in and lead out that we're going to use again is going to be perpendicular, so we're going to click on the entity here to turn this on. We'll make sure that our length is set to 0.1, and we're going to copy these values. We have our sweep already at 45. We'll copy these values over to the other side. Now this will extend and shorten the moves of cutter compensation, or actually the contour itself. We want to make sure that that is turned off. We don't want to have any extensions other than this setting right here. Breakthrough is going to be off, multi-passes is off, tabs are off. Now we go to our linking parameters. Again, we make sure everything is set to absolute. Our clearance is 1, our retract is 1/4, our feed plane 0.1, and our depth of cut here minus 0.125. Again, we'll click on coolant to ensure that flood is turned on, and we'll say OK. Now if I play that one back, I click on the tool paths, the play bar comes up, I click it, and you'll see the tool will come down, and then it'll move to the next one, and I'm going to speed that up with the little arrow here, the speed arrow, by moving it to the right, and you'll see the tool will come down and cut the wheels. Now that that operation is complete, we have one operation left, and that is to do all of the doors, lights, pinstriping, the engraving using Tool 3 going 110 thousandths deep, 15 inches a minute. So I'm going to come to my levels at the bottom left. I'm going to turn those features on, and then I'm going to go back to Toolpath. I'm going to right click in the Toolpaths menu and come and do another contour operation. This time I'm going to leave the chain operation, the default chain operation on, and I'm going to just select each one of these pieces of geometry. So I'm going to click here, and it doesn't matter the order that you want to do it in. To be efficient, I'm kind of working downward, so I'm not sure I picked the right one there. So let's go back. And if you pick the wrong piece of geometry, you can use these settings right here. I'm going to say unselect the one I just picked. I meant to pick the little hubcap here. There we go. And then the door, and then the window, and then the door handle, and then this pinstripe, and then let's do this hubcap, and then let's do this tail light. And let's come over here and do the same thing. We'll work our way up. We'll do pinstripe, the door, the window, this pinstripe, the hubcap, and the headlight. So once all of these are selected, I say OK. I go to my tool, and this time we want to use tool number 3, which is the center drill. So make sure again that tool number 3 is populated in these 3 registers. And for this particular tool, we're going to run it at 15 inches a minute, but we can spin this tool a little bit faster. So let's change this RPM to 2000 RPM. Let's change our feed rate to 15 inches a minute. And let's make sure rapid retract is turned on. Our plunge rate is awfully slow here. I'm going to change that plunge rate to 5 inches a minute. And I'm going to just type the word engrave for our tool comment. Now, under cut parameters, we're set to cut or left. We don't want to be left of these lines. We want the tool to run right down the center. We don't want any cutter compensation at all. So we'll click in this little drop down and say turn cutter compensation off, and double check that the icon shows that the tool is running down the middle. Depth of cut, we don't need any depths of cut. Our lead in and lead outs need to be turned completely off. We don't need to see any lines leading in and leading off of these. We just want to plunge right down to depth and cut these little features. Again, breakthrough multipass tabs are turned off. We go to our linking parameters. We again make sure that everything's set to absolute, 1 inch, 250, 0.1, and remember the depth that we're going is 110 thousandths deep. Basically, we're going to engrave 10 thousandths deep, and because the pockets are already at 100 and we're working in absolute coordinate system, we have to go 110 thousandths deep negative, minus 0.11. From here, we ensure that our coolant is turned on, and we say OK. And then once again, if we want to check that operation, we simply click on the toolpath here, brings up our backplot menu, and we can see it mill all of these features. If we're satisfied with what it's doing, we're going to click OK. And now what we're going to do is we want to verify this. We want to see what is this going to look like in the actual cut material. So to do that, we need to describe the stock size that we're using, which is this mold-based plate here. If your toolpath menu is not expanded where it says properties, just click the little plus sign and then click on stock setup. Make sure that it's set to rectangular shape and then click on select corners. Pick the upper left-hand corner, then slide down to the lower right-hand corner. That'll populate these values for you, and then give it the thickness of this plate, which is 0.375. That's the thickness of the acrylic plate that you'll be using, and then say OK. From there, we want to make sure that all these operations are selected so we can actually watch them machine. If you only have one selected, that's the only one that'll play back in this verify method. To select all these operations at once, these 4 little blue dots, just click on them and you should see a check mark on all the operations. So from here, what we're going to do is we're going to go to the verify selected operations icon. This will open a new window, the verify window. It might take a few seconds to load. You're going to right click somewhere on the screen and you're going to go to isometric. That changes your view. If you don't want to see these wireframes that's on the drawing here, or I'm sorry, on this graphic, you can come up here and turn the wireframe off by clicking that little check mark. Set your precision somewhere in the middle, and let's slow down the path just a little bit, maybe about to here, so you can kind of see everything happen. We'll click on play, and we'll see it'll spot the holes, do the scribe line, drill the holes, ream the holes, pocket out the truck body on both sides. Then it'll come back and finish the last 10 thousandths with the contour. Then it machines the wheels, and then it comes in and does all the engraving of the truck features. So if you want to get a better view of what's happening here, you can click in the middle mouse button here, and I'm seeing that my hubcaps didn't show up. The hubcaps obviously need to be done slightly deeper on this one, so I can take those off from the one operation and add them into a separate operation. So I'll show you how that gets done. So I'm going to click out of here briefly, go back into my geometry and go back to top. And this is good that I made this mistake. I didn't mean to, but I did, so let's show you how I correct it. So in this last contour, if I click on geometry, I'm going to see all of the chains that I had here. And if I select one of these chains, for instance this one, it should show up in the list. And if it doesn't, I'll just start clicking through here, and as I do that, you'll see on the drawing side here, for instance, this one is that little window. And I'll just kind of go backwards through it till I find that wheel, that one right there. And we're going to delete it. So I'm just going to hit the delete button on that one, and then I'm going to continue back down the list here on each one until it highlights the hubcap. Let me see, let me go back through here, here, here. There it is. We'll delete that one. And then we'll come back down to the other one on the bottom right. There it is, it's highlighted. So we'll delete that one. We've already deleted the lower left one, and I believe if I go backwards through the list there, we can delete that one. Just to ensure that I did it correctly, I'm going to click OK. Anytime you change an already existing operation, it becomes dirty. You can tell it's dirty by this red X. So you just click this icon that says regenerate all dirty operations, and regenerate that operation. And I just want to make sure that I'm still engraving everything I want to. So I'm going to come in here and just check it real quick. There's the door, the handle, the tail light, and it's skipping those 4 hubcaps. So I'm going to create a new contour operation for just these hubcaps right here. I'm going to right click, middle toolpath, contour. Again, I'll use the chaining operation, and I'll click the 4 hubcaps. Doesn't matter which direction we mill these in because there's no cutter compensation being used. Now these wheels were milled at 125 thousandths deep, so to go 10 thousandths deep, what we'll do is make sure that the right tool is picked, tool 3. Our feeds and speeds are still the same. I'll put in here a comment that says engrave hubcaps. And then I'll go through my parameters and make sure that they're set. Cutter compensation should be off, no stock to leave. These are all off. We just go right to our linking parameters, and we make this minus 0.125 for the wheel, and you can add minus 0.01 and you'll get negative 1.125. All of these boxes are live boxes that you can actually do math in. So if you don't know exactly what depth you're going to, you can actually use the method that I just did by taking your original amount and adding to it. Again, your coolant should be on, so check to make sure flood is turned on, and we're going to say OK. And that operation should now be all right. Let's check it in back plot here. There it is. There's the other one. Come over to this one, and then the upper right one. Looks great. I'm going to say OK. We're going to select all of our operations again, go right back into our verify, and we're going to go to our isometric view, and all our settings should still be there. I'm going to go ahead and then click play again, and hopefully it does it correctly. Pocketing, finish contour, tires, engraving, and then the 4 hubcaps, and there they are. That's what we wanted to see. So that looks great. Okay, it actually gives you a little bit of a cycle time here too. It's going to take about 9 minutes to machine this particular program on the Fidel machine. Remember that in your homework assignments, what you need to give me is a printout of this screen. So the way that you're going to do that, unfortunately you can create a video. I don't want to see a video of it. I just want to see a printout of it. And the only way to do that in Mastercam is to use your print screen button. So I'm going to press my print screen button here. That, you can't see it one that I just pressed it, but that just copied this image to the clipboard. From here, I'm going to X out of here. I'm going to go back to my Mastercam main menu, go back to top view. At this point, make sure that you save your drawing and your file that you just created. And the next thing I'm going to do is come down to Windows, and I'm going to, in the search bar here, type the word paint, press enter to open up the paint menu, and then I'll click somewhere in here. I don't think I have to click in here, but I'm going to. I'm just going to click Control V. That pastes this picture in. You're going to want to say File, Save As. Choose, instead of this PNG file format, let's make it a JPEG. So say JPEG. I'm going to call this one TRK for truck dash my initials. And I'm going to save it to the desktop. You can save it to wherever you'd like. I'm going to say OK. And then I'm going to click File. And I'm going to send it to my printer. And click OK. Or I'm sorry, Print. And now I've sent that file to my printer. Remember, on your drawing, you want to make sure that you put your name, your Panther ID, and your lab number so I know it's yours. And what am I going to use this for? This is going to give me a quick overview to see if what you wrote as a program looks correctly. So we're still going to verify your program in the classroom before we run it, but by looking at this I can tell right away if there's something wrong. So I'm going to close the paint program. Again, make sure that your file has been saved. And that pretty much ends this video tutorial. Thank you for watching.